Good morning, dear friends. Today we discuss about the atomic radius or the ionic radius. This is very important topic before we study of the periodic table, modern periodic tables. Then in the atomic or the ionic radius that is the distance between the nucleus to the outermost electron is present in the outermost orbit. This is known as the ionic radius or the atomic radius. The term atomic or the ionic radius is generally used the distance between the nucleus and the outermost shell of an electrons of the atomic or the ionic particles. Then it is impossible to isolate and the individual atoms or an ions, that is we cannot isolate or it is impossible to isolate an individual atoms or an ion. It is possible to measure the atomic or the ionic radius, and the quantities are however generally derived in an indirect manner. uh, then these are the and this is not possible to measure atomics and ionic radius. These quantities are however generally derived, that is the indirect manners, from the measured distance between the nuclei and the two bonded atoms in gaseous molecules or between the nuclei of two ions in solid. That is the former case. These distance are called as the internuclear distance. This distance is between the atomic nuclei, two atomic nuclei of ions. This is the internuclear distance. In the latter case, these are called as the interionic distance. The internuclear distances in covalent substances or interionic distances in ionic substances are generally determined by the X-ray diffractions, electronic diffractions, and NMR spectroscopy techniques. Then, what are the factors? Depend upon these atomics or the ionic radius. The following factors, that is we discuss about that factors. First is the multiplicity of the bond, that is the if single bond, double bond, or the triple bond. If suppose the carbon carbon single bond, or the carbon carbon double bond, or the carbon carbon triple bond, that is the atomic or the ionic radius depends upon the multiplicity of the bond is also. If the carbon carbon single bond is present, then the distance between these two carbon atom is very larger than that of the double bond and the triple bond. It means that the carbon carbon triple bond having the atomic radius is very ionic radius between these two carbon atom is very less as compared to the carbon carbon single bond and the carbon carbon double bonds. And then the second factor is to the extent of covalent bonding, that is the covalent bonding is the major factor of the atomic or the ionic radius. Then the third factor is the oxidation number of an atom, which indicates the number of electrons involving in the bondings. Number of electrons are involving in the bondings. Then the fourth factor, that is the repulsive forces between the atoms and directly bonded to each others. This is one the factor depend upon the atomic and ionic radius. Then the another factor is the number of neighbors with which it is associated. Means neighboring elements are which factors, which compound is associated with that compound, or the bulkier molecule will be there. That is the number of neighbor with which it is associated with the atomic radius. Then the another topic, that is the classification of the radii, atomic radii. Atomic radii are the subdivided into there are three types or the three classes. First is the covalent radii in non-metals and in covalent molecule in general. Then the uh, another type or the another class is the metallic radii in metal or allow or intermetallic bonding. Then the third is the van der Waals radii. They, these are the types of the atomic radius. These are the types of the radius. And first is the covalent radius. Covalent radius, it is defined as the half of the distance between the nucleus of the two like atoms. Like atoms, that is the chlorine chlorine, fluorine fluorine, bromine bromine. Like this, these are the hydrogen hydrogen bonding. These are the like atoms bonded together by a single covalent bond. Thus, covalent radii are essentially single bond covalent radii. Then this consider the homonuclear diatomic molecules, that is the it having the two like atoms, that is it means that the chlorine chlorine Cl2 and bonded together by covalent bond, and if these molecular the two like atoms are regarded as the effective space in close contact with each other, then according to the definition of the covalent radius, the distance between the nuclei of these two atoms, that is the bond length in the internuclear distance, that is chlorine chlorine, fluorine fluorine, fluorine single bond fluorine, bromine single bond bromine, or iodine single bond iodine, and should be equal to the sum of single bond covalent radii of these of the both the atoms. That is how we can calculate the small d, that is the any element chlorine single bond chlorine is equal to the radius of chlorine first atom, or the plus chlorine radius of chlorine second element, that is same element having the single bonds. The radius of, if we want to calculate the radius of chlorine, is equal to the distance between the chlorine first minus the chlorine second divided by 2. So this is the formula where the radius of chlorine is the single bond covalent radius of atoms chlorine. So this is the covalent radius and covalent radii or the covalent radii of the any element same atomic homonuclear atomic atoms. And then in order to calculate the covalent radii of an atom in a heteronuclear diatomic molecules, if the HCl molecule is present, diatomic molecules, the substitution method is used if the internuclear distance between the two similar atoms, like the, that is known as the here distance between the A dash B, it means that the H single bond Cl is equal to the radius of a hydrogen atom plus radius of the chloride atom. Here the when Xa is equal to the Xb, it means that the Xa is not equal to the Xb. It means that the first element is not equal to the another element that attached with the that elements. HCl, suppose an example of HCl is the heteronuclear atoms, heteronuclear covalent radii. In the HCl atom, the heteronuclear diatomic molecule, and this is we can calculate by the radius of formula, that is the distance of HCl, H single bond Cl is equal to the radius of hydrogen plus radius of chlorine. Then if the Xa, it means that the X hydrogen atom is not equal to the Xb, it means that the HCl is experimental value distance of AB, it means that the HCl is less than that of the that of the obtained by the sum of radius of single first element and the radius of another element attached with these elements, and is evident from the following examples. So uh, this is the covalent radii calculation part, and then there is a division from the expected value, which is due to the difference between the electronegativities of the two dissimilar atoms. Electronegativities with the two dissimilar atoms according to the Schweimaker and the Stevenson, the actual bond distance between the A and B. It means that the first element and the second element is given by the formula, that is the radius of A single A minus B. It means that the HCl is equal to the radius of first element plus radius of second element minus 0.09 in bracket xm minus xb. So this is the Ra and Rb. It means that the covalent rate of element, that is the element A and B atoms, are respectively X and Xb is the electronegativity of the atoms of A and B atoms respectively. The covalent radii, single bond covalent radii of for the S and P orbitals, S and P block elements, the covalent radii of various elements. Already we discussed about the covalent radius, the electronegativity of these elements, the covalent radius of various elements, that is the hydrogen having the covalent radius is 0.37, helium having the 0.93, lithium 1.34, beryllium 0.90, beryllium 0.82, carbon 0.77, nitrogen atom having the covalent radius is 0.75, oxygen 0.73, fluorine 0.72, neon 1.31. Like this, these are the continuously, it means that the covalent radius is from left to right in the periodic table, the continuously decreases. Covalent radius is decreases by, but while in case of these inert gases, they not change in the inert gases. This is then increases in inert gases. Then sodium having the 1.54, and magnesium 1.36, aluminum 1.18, silicon 1.11, phosphorus 1.06, silicon 1.09. It means that the continuous from left to right, the atomic or the covalent radii is decreases but not changes in the inert gases or the group 8th elements. So this is the atomic or the ionic radii. First example, first type, already we discussed about this first type, that is the covalent radii. Then we discuss later on we discuss, that is the metallic radii in metal and the van der Waals radii.